Hi folks! Today we're going to be talking about how to prove that two lines are parallel using the converse of the theorems and the postulate that you've been talking about for the last few days. For example, you've talked about the corresponding angles postulate. By the way, that's the only one that's the postulate. The other four are all theorems. So the corresponding angles postulate can actually be used to derive the other theorems, so that's why we call it a postulate. So it's the only one. The other ones are theorems. But from my angles and parallel lines notes, the corresponding angles postulate says that if two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. So we're going to take those postulates and theorems today, and we're going to actually use the converse to instead prove that the lines that are cutting the transversal are the parallel ones. So today, the converse of the angle pair postulate and theorems we've been using can be used to prove certain lines are parallel. So that's our goal today. So let's look at the converse of the corresponding angles postulate. It says, if two lines cut by a transversal form congruent corresponding angles, so the corresponding angles are congruent to each other, then the two lines that are cutting that transversal are parallel to each other. So it is exactly the converse of what the actual postulate says. So an example might be that if we have, let's pick a pair of corresponding angles. Let's say angle, let's make a drawing tool. Let's say that angle 1 is congruent. There we go. Let's say angle 1 is congruent to its corresponding angle, which would be angle 5. So if we have that situation, then, we would be able to say that the lines that are cutting that transversal are parallel to each other. So we would be able to say that line L is parallel to line M. So if angle 1 is congruent to angle 5, those corresponding angles are congruent to each other, then the lines L and M must be parallel to each other. And that's by the corresponding angles postulate converse. So the converse are the ones that show that the lines are parallel. So let's try another one. The consecutive interior angles theorem converse. Remember, consecutive means same side and interior means inside of the lines. It says if two lines cut by a transversal form supplementary consecutive interior angles, then the two lines must be parallel. So again, let's pick a pair of consecutive interior angles and let's say that they're supplementary. So the measure of angle 3 plus the measure of angle, what is the consecutive interior angle that matches this pair? Angle 3 and angle 5. So if you add those up and you can get 180 degrees, then we can say that line L is parallel to line M. Okay? So as long as we can make these claims true, we can either make these angles congruent or we can make the angle pair supplementary, then we can show that these lines are congruent to each other. So let's move on to the consecutive exterior angle theorem. So it's the same thing just with the exterior angles that are consecutive. If two lines cut by a transversal form supplementary consecutive exterior angles, then the two lines are parallel. So again, let's pick a pair of consecutive exterior angles. So let's talk about angle 2. So the measure of angle 2 plus the measure of angle, what is its consecutive exterior angle? We've got angle 2 and angle 8. If it equals 180 degrees, then what can we claim? we can claim that line L parallel to line M. So notice that the conclusion for all of these examples is that line L is parallel to line M. That's the claim that we're making. So what I'd like for you to do is try to come up with an example after you read the converse of the remaining two examples. So come up with your two examples. Pause your video. Okay. So for the alternate interior angles theorem converse, we say that if two lines cut by a transversal form those congruent alternate interior angles, then the two lines must be parallel. So the example could be that if angles 3 and 6 are congruent to each other, then line L is parallel to line M. You could also have said if angles 4 and 5 are congruent to each other, then you can claim those lines are parallel. So either 3 is congruent to 6 or 4 is congruent to 5. Either of those are fine. And finally, we have the alternate exterior angles theorem converse, which says that if two lines cut by a transversal form congruent alternate exterior angles, then the two lines are parallel as well. So we could either talk about if angle 2 is congruent to angle 7, or if angle 1 is congruent to angle 8. Then lines L and M are parallel to each other. So let's go ahead and scroll down. Let's get to our examples. The instructions say, identify the parallel lines, then explain your answer using a postulate or theorem. So we're using that diagram to the right side. We're answering a lot of different questions about them. Keep in mind that here it says, given that the measure of angle 3 is equal to the measure of angle 1, that could have alternately been written as angle 3 is congruent to angle 1. So those are very related statements. The measure of angle 3 is equal to the measure of angle 1 means that angle 3 and angle 1 are congruent to each other. So given that the measure of angle 3, so here is angle 3, is equal to the measure of angle 1, which lines are parallel? So look at the lines that are creating those angles. The only one that has nothing to do with those two angles is line M. So that means line M is not going to get used. That means line L is the transversal, and that means that line A and line B are the two that are parallel to each other. So let's talk about why. So if I look at my diagram, and I look at angle 1 and angle 3, you need to identify the type of pair that they are. Well, angle 1 and angle 3 are in the same location with respect to the intersection of those lines, so that means that those are corresponding angles. And those corresponding angles are congruent to each other. So this is the corresponding angles postulate, but it's the converse. So the converse is what proves that the lines are parallel, not the postulate itself, but the converse, because the conclusion of the converse is that the two lines are parallel. So let's look at the next one. It says, let me erase my marks here. It says, given angle angle 1, so the measure of angle 1 is equal to the measure of angle 5. So those two angles are congruent to each other. Which lines are parallel? So again, look at the lines that are being used to create those angles. We have line L, and then we have lines A and B that are going through line L. So L must be the transversal, and lines A and B must be parallel to each other. Line A, line B. So let's talk about why. Angle 1 and angle 5 are an angle pair. They're both on the outside of lines A and B. They're both on different sides of the transversal L. So those two angles are alternate exterior angles. And if alternate exterior angles are congruent to each other, then that proves that the two lines that create them are parallel. So we're going to say by the alternate exterior angles theorem, but it's converse. It's the converse that shows the lines are parallel, not the theorem itself. Okay, we'll do one more together. Let's talk about part C. So I'm going to erase my marks on my diagram. Part C says, given the measure of angle 7 plus the measure of angle 6 is equal to 180 degrees, which lines are parallel? So notice how I didn't mark them with the same number of arcs? That's because angle 7 and angle 6 are not congruent to each other. They add together to give us 180 degrees, which means they are what? They are supplementary. So if those two angles are supplementary, look at the lines that are creating them. We have line L again. Line A and line B are also creating them, so that means L is the transversal. Line A must be parallel, to line B. And let's talk about why. So look at that angle pair. That angle pair has angles both on the inside of lines A and B, and they're on the same side of transversal L. So that means that these are same side or consecutive interior angles, but it's by the theorem's converse. Not the theorem itself, but its converse that proves that the lines are parallel. So what I'd like for you to do is move on to part D and part E using the same diagram. I'd like for you to complete those two while you've paused your video and then turn it back on to check back and make sure you got the right answer. Pause your video. So part D mentions that the measure of angle 15 is equal to the measure of angle 11. So angle 15 is here, angle 11 is here. If they are congruent, and those are alternate interior angles, then by the alternate interior angle theorem's converse, line A and line B must be parallel to each other. Part E says that the measure of angle 16 plus the measure of angle 13, so this angle and this angle, their measurements add to be 180 degrees, meaning they are supplementary. And it wants to know which lines are parallel. Those two angles are same side or consecutive exterior angles, and because they are supplementary, that means lines A and B are parallel to each other by the consecutive exterior angles theorem converse. So it's the converse that proves that the lines are parallel. It's the actual theorems or postulates that prove that we've got congruent or supplementary pairs of angles. So I'm going to go ahead and scroll down. The last little bit of our notes is example 2, and it's a proof. So just like yesterday when we talked about our algebraic proofs, we're going to do our geometric proofs today in a 2-column proof format. So we're going to have our statements on the left, and we're going to have our reasoning on the right. The reasoning can be any of the postulates or theorems. It could be the converses of the postulates or theorems. It could be any of the algebraic properties of equality or their properties of congruence, because any algebraic property of equality also has a property of congruence that's related to it. So it could be any of those for the reasoning. One of the things that I do want to mention in a 2-column proof is that the statements that are given, you use them when you need them. So you don't just throw them in at any time. Once you have a logical flow for your argument, those given statements should be inserted when they're needed. For example, it says, given that angle 1 is congruent to angle 4. So here angle 1 is congruent to angle 4. And it says that angles 3 and 4 are supplementary. So angle 3 and 4, this one and this one, are supplementary to each other. And I need to prove that lines L and M are not congruent, but parallel. So that means I need to make some kind of relationship between the angle pairs that's created with lines L and M. So maybe these two right here. So I'm going to start out, there we go, by my given statement that angle 3 and angle 4, there we go. Angle 3 and angle 4 are supplementary. And the reason is that that's given to me. Okay? Maybe I'll try to align my reasonings over there. So the reason is that that's given to me. I also happen to know that angles 2 and 3 are vertical angles, which means that they also are congruent to each other, right? So that's something else that I know. That angle 3 is congruent to angle 2. And that reasoning is the vertical angle theorem. The vertical angle theorem states that a pair of vertical angles are congruent to each other. Okay. I also know that angles 1 and 4 are congruent to each other. How do I know that? It was given. It was the first thing that was given. So if I know that angles 3 and 2 are congruent and angles 1 and 4 are congruent, that means that I can replace angle 1 with angle 4, and I can replace angle 2 for angle 3. So that means that I can replace this angle 3 right here with angle 2, and I can replace this with angle 1. So I can say that angles 1 and angles 2 are supplementary. And the reasoning is because I can substitute angles 2 and 3, and I can substitute angles 1 and 4. So that's the substitution property of congruence. Okay. So by now, I've claimed that angle 1 and angle 2 are supplementary to each other. Those two angles are consecutive interior angles, and if they're supplementary to each other, then we know that the lines that are creating them along with the transversal must be parallel, and that would be line L and line M. So I can say, therefore, and those three little dots like that in math mean therefore. So it's usually what you say at the end of the proof. So therefore, line L is parallel to line M. And the reason is because they're consecutive interior angles and they're supplementary to each other. So that's the consecutive interior angle theorem converse. And I'm not sure if we have this in the equation section. We don't. But typically at the end of a proof, to denote that it is the end of the proof, you have a little square. And you can color it in if you want. I typically do. But it just shows that it's the end of the proof and that you finished it, and this line has your conclusion on it.